Hello, let's continue our Sudoku adventure with Elevation by Microstudy. So this is going to be an irregular Sudoku with skyscraper clues. So let's go over what that means. So in irregular 6x6 Sudoku, it's still in every row and every column. We're going to be placing the digits 1 to 6 exactly once each. But there's also these groups of 6 cells that have a bolded outline instead of the normal 2x3 boxes. We don't have the normal boxes, and instead we have different regions that are these different irregular shapes. That's why it's called irregular Sudoku. And so we are within these regions also placing the digits 1 to 6 exactly once each. We also have skyscraper clues outside the grid. So these are a little bit difficult to explain, but not that hard conceptually. So the idea is let's fill a whole row. Let's just fill an empty row with no clue in it. How about 4 to 5, 1, 6, 3. So let's say there was a clue here. I can tell you right now the skyscraper clue for this row would be a 3. And the way that works is you start from that side of that clue, and then you always see the first cell in that direction, and then you only see cells that are larger than the previous one you've seen. So we'd see these 3, but these 3 would be occluded. And it's called skyscraper because you can think of them as skyscrapers of that height. So the first skyscraper we see is 4 stories tall. There's a 2 stories tall one behind it, but we can't see it. It's blocked by the 4-story. But then there's a 5-story building, and you can see the very top story of it, so you can see it. Then the 1 is hidden by the 5 and the 4, and the 2 actually, so it's just completely hidden. Then the 6 can be seen because it's taller than the 5. And then the 3. Now if I swap this 6 and 5, now this would be a 2 clue. We would not see the 5 because the 6 is taller than it. So the 6 hides the 5. So hopefully that's clear. That's how skyscrapers work. So this 2 means we see 2 in this direction. This 5 means we see 5 in this direction. All right, so that is how those rules work. If you want to give this puzzle a try yourself, there's a link in the description, and I'm going to get started right now. Okay, so one obvious place to start is right here, which is a 1 skyscraper clue. No matter what, you're going to see the 6. You always see the 6 because nothing can be taller than it. And so in order to only see the 6, this has to be a 6. The 2 is a bit more flexible, right? So the first one could be 1 through 5. We just have to make sure then that we occlude everything until we hit the 6, and then everything after that's fine. So 2 is a little bit harder. 5 is interesting, especially because this can't be the 6. So the 6 at its latest is here, and if the 6 were any earlier, we would only see 4 or fewer. So this actually has to be the 6 for this 5 clue. And then these need to be in order. So this could be, essentially it's like a thermo, right? So this could be like 1, 2, 2, 3, 3, 4, 4, 5. And then whatever's missing from here of 1 through 5 goes here. All right. This 4 doesn't have as much. Actually, the 4 has the same deal because the 6s now can't be in these 2. So this has to be the 6. Otherwise, we'd have too few seen skyscrapers. And then these have to increase. So this is 1, 2, 3, 2, 3, 4. Oops, 2, 3, 4, and 3, 4, 5. If you think about it, like if this was a 5, you'd never see this one. So you'd only see 3. Okay, so we have we don't quite have a quad or anything here. That's interesting. Does this 2 get affected by these? Maybe, maybe not. Okay, I can say this can't be a 2. That's for an interesting reason. If this was a 2, it forces this to be a 1 for the 4 skyscraper clue, but also forces this to be a 1 because it shares a region. So again, if this was a 2, this would be a 1, and this would be a 1, and that wouldn't work. So this can't be a 2. So that means this can't be a 3. There's probably some geometry with the regions that I can do that I haven't looked at yet. 6 in this region is in one of these 2. This would make a lot of sense to be here because it would make the 2 clue work. But it doesn't have to be. 6 is in one of these 2 in this region. Ah, but it can't be here. Right. This region has 6 here. So this can't be a 6, or this region would have no place for 6. So this is the 6 in this region. This is the 6. And we can place the last 6 in this corner here. Nice. So this cell and this cell are the same digit. You can use colors to represent that. I think it could be really anything, though. Anything 1 to 5. Oh, and in this region, this sees all of that, so it goes here. Let's see, in this region... Yep, in this region it goes here, so it's a 3 or a 4. We can fill that. And then... Yep, in this region it goes here. It's the same 3, 4. And then we have one more place for it, which is right here. This is a 3, 4. We've got this sort of diagonal pattern going on here. Did we learn anything about it? Not really. Okay, so what else can we do? Maybe we can work, maybe there's something backwards that works the same way. Or not. I'm looking for more geometry like that. Is it this 2? Oh, this 2 is interesting. Okay. The 6 ended up really far away from this 2. So we need the 5. We need a 4 or a 5 here. If you think about it, if I put a 3 here, I can hide one of the digits bigger than 3 back here. I can hide a 4 or a 5 back here, but then there's going to be another one over here, and I'm going to see that before I see the 6. So this needs to be a 4 or a 5, and that does make a 4-5 pair, and that makes all of these greens a 3, which is quite useful. You don't need to color it anymore. This is a 2, this is a 1. Now that's a 2. Very nice. Okay, so now because of the 4-5 pair, we can actually do more, because if this was a 4, that's actually a problem. It makes this a 5, and now we see 3. So this has to be the 5. This is the 4. Did I say these are the same? I don't think I did. I don't think they are, or they don't have to be at least. This is a pair left. We have a few pairs left in rows, so let's do that. This is 1 or 2, and this 2 in the same region sees here. And then this is 4 or 5, and we can just fill those because of this 4 in the region. This is a 5. That's a 1. That's a 2. And I think we can just finish now. This is a pair. We need 4 and 5. This is a pair. We need 1 and the 1 goes here, right? Because there's a 1. And we need a 4. So that's 5 and 4. Oh, this is known. This is a 4. This is a pair. 1 goes somewhere and 4 goes somewhere. So these go this way because of that 4. This is a pair. We need a 1 and we need 5. This is known. This is a 2. And here we need a 2 and we need a 5. Nice. Correct solution. Very good. Cool. Well, I liked that. That was a good demonstration of both irregular geometry as well as how skyscrapers work. So thank you, Microstudy. I enjoyed the puzzle. And of course, if you enjoyed the puzzle as well, then why not leave a like, subscribe, and a kind comment below.